Hello, my name is Ashley Kipp, and I will be talking about some landscape changes on Sapelo and Blackbeard Island, Georgia, usually just referred to as Sapelo. So some background about the island. They are barrier islands right off of the center of the Georgia coast in McIntosh County. They're only accessible by the Sapelo Ferry, which you actually have to apply to be able to get on, boat or aircraft. And the islands are primarily wetland vegetation. There are some communities, some of which are the only intact island community of the Gullah Geechee, located at Hog Hammock. The Gullah Geechee are actually descendants of enslaved individuals that were brought to Sapelo back in the 1800s when it was primarily run by plantation owners. After emancipation, they decided to stay and purchase up the land, but they have had to move due to other acquisitions on the island. The other inhabitants, so to speak, are the environmental reserves, which include Sapelo Island National Estuarine Research Reserve, and the rest of it is run by the Georgia Department of Natural Resources. So this is just a map showing some of the points of interest on Sapelo, including that hog hammock community that I mentioned right here in the yellow, and the boundary of that research reserve. If you click on any of these, it'll give you some information. This is a bourbon field, which is actually an archaeological site. And if you click the URL, it'll tell you a little bit about each of those point of interests. Now, the vegetation, like I said, is primarily wetlands. Those wetlands are large stretches of tidal salt marshes, primarily. Those are going to be filled with cordgrass. There's a lot of live oaks in the maritime forests. There's those sand dune areas and some freshwater wetland areas spread throughout. It is a pretty unique ecosystem, and the estuaries allow for a lot of wildlife, including alligators and even a bit of a feral hog problem on the island. So if you look at the National Wetlands Inventory, you can see the distribution of those wetlands on the map here. Like I said, most of it are these tidal marshes. There are freshwater and a few brackish or transitional wetlands, but a lot of this is upland or some agricultural areas as well. Here are just a few pictures of those different types. There's some cordgrass here. There's a freshwater and some live oaks. So I was primarily looking at some of the bigger changes that have happened over time that have been detrimental, so to speak, to the island. So the vegetation of the islands, I was able to look at those more intense changes using the collaboration between the U.S. Department of Agriculture and the Forest Service for their landscape change monitoring system. So what we're looking at here is actually the areas of what they call fast loss, which is moments of rapid vegetation loss throughout periods of time. A lot of these losses are a result of fire, harvests, or a lot of flooding, inundation. From this, I was able to see that there were two major events that step out. You can look at the types here. The darker colors are more recent, the lighters are older. And those are going to be the ones that happened in 2017, culminating in 2019, and then in 2012, which is in this area here. Now, on the other side of that, you can look at vegetation gain moments throughout the years using that same LCMS system. So after the 2012 event, there is some vegetation gain in 2013, but after the 2017 event, there really isn't much. Now, unfortunately, I wasn't able to find a lot of good imagery for 2012 to really mark that change, but I do know that there are controlled burns by the research center there and some wildfire events within that time frame. But like I said, that is just my best guess based on the trends that I've seen. The event in 2017 is related probably most likely to Hurricane Irma, because that caused a lot of damage to the island and a lot of shoreline change, and it even created a small island separation that I will show later on. if you put both of those on top of each other, you can see the areas where there hasn't been any vegetation gain after the event. So those are going to be your areas of red on this map. And as you can see, those areas are primarily along the shoreline. So that is what I decided to primarily focus on with this project. This is just a graph to better highlight what I was speaking on in these previous maps. You can see the jump after 2012 into 2013, and then in 2017 you don't really see that as much. So using some Landsat 8 imagery from August of 2017 versus September 14th, 2017, which is just 4 days after Irma hit Sapelo, you can look at the creation of what they called Little Blackbeard Island. That was caused with that and some of the more degradation of that shoreline, erosion of that shoreline, and some southward island accretion. So if we just look here, you can see that separation happening right here in the middle, and some flooding up here, and the reduction of that shoreline. Now, I'm not going to play this whole video, but it is a time series covering the event of Irma, and I did want to show some of the photos at the end, which are focused on beach and sand dunes. So you see all the sand dunes here, and this is after, on that same date that I have that imagery from. It's completely gone. Now, along with extreme erosion and shoreline events, like I mentioned, there is some accretion to the south of the island. So this general migration of barrier islands is caused by prevailing winds and currents over time. And here it is generally a north to south movement. Now I wanted to show a pretty stark change of that. So I found some imagery from 1942 that's been mosaicked and some NAIP imagery from 2021 to show this change and focused on that southernmost point of Sapelo. Now, the new expanse that you'll see here that's ridged is going to be now interdune meadows, which are a freshwater habitat that is really important to many different types of species on Sapelo. And like I said before, that those areas are pretty limited. And as you see, that's pretty intense change there. So using a combination of shoreline data ranging from the 1800s to 2018 and linear regression methods using the digital shoreline analysis system in a project run by USGS, you can look at those long-term shoreline change rates in this area. This helps to pinpoint those areas of the shoreline that have experienced the most change and also visualize that southward accretion that we've been talking about. So here's just an image of that. Now the red areas, that's where there's been a loss of 2 meters per year. So you can see that at the northernmost tip, and then a gain of 2 meters at the bottom here. It's a somewhat mixed bag going through the middle here. And mostly you're going to see a lot of that damage coming from storm surges. And you can see here, this orange area where there's the loss is actually right next to that hog hammock community. So you can't talk about shoreline change without speaking on sea level rise. Now that does greatly affect barrier islands, although usually they can migrate on their own. But with human development and intervention, that can sometimes hinder that process and cause just straight loss of the shoreline. Additionally, with the anthropogenic climate change, you're going to see a lot more storm surges, inundation, and some saltwater intrusion that has that negative impact on those ecological systems, but also the coastal communities in the area. And with the sea level projections as they are, there's expected to be a rise of between 10 to 14 inches on the East Coast with that relative sea level rise. within the next 30 years, and there's up to a risk of 2 feet sea level rise by 2100, according to the NOAA. So to visualize that, I'm showing the 1 foot scenario and the 2 foot scenario along with the current mean higher high water, which is kind of showing in this dark color where the current high tide flooding rests on there, along with the developed land of the area. So you see, like Hog Hammock here is going to experience a lot of issues with sea level rise in the very near future. So Sapelo and Blackbeard Island have experienced a lot of changes to the landscape, and by using the LCMS data, you can look at those areas that have experienced a lot of loss but not have necessarily gained anything back. So tracking these changes over time creates a better chance of predicting future scenarios for these communities that are there and these research centers. Of course, this project can look at a lot of things. So there's a lot of space for future research and improvement. The changes in shoreline and sea level rise will continue to impact that vegetation, and you will see a greater impact as time goes on. So for the future research, I would be interested in looking at the resiliency of the freshwater and saltwater marshes in the area. And I would like to use the information gathered to better pinpoint the more at-risk areas for change on the island, especially for the at-risk Gulagichi community. So thank you for listening. These are my references.